Hey guys, Millie Bays here. This is my partner Mark. Let's wake him up.
Zach, why are you in my room?
We're doing our SAS project. Hey, have you guys ever sat there thinking about a test statistic or population mean you've been reading in a sports article and wanted to test it yourself?
No!
Neither have I! Today we're going to show you a small few amount of people how to do it. Hey guys, it's Millie Bays again. Mark's getting cleaned up, so I'm going to go ahead and tell you all about this package. And this package is the same as the last one, but instead of population proportions, we're doing population means. See, we still have the 5-step process. It's simple, the HMC cubed, right? And for this, the slight difference is in the hypotheses, right? Instead of using the variable p, we'll be using mu to represent the means, right? So for h null, we have mu is equal to mu naught, whatever we're trying to disprove. And then we have the alternative hypothesis, HA, right? And this is where mu is less than, not equal to, or greater than mu naught. And the conditions for this one are different than the population proportions. The conditions would be, just like the population proportions, it's random or representative, but the second condition varies, right? This one, for the second condition, it could be either the population distribution is normal, which an example problem might tell you that it's normal, or you might have to graph it on a box plot to figure out whether or not it's normal, or if the population, or the sample rather, is greater than or equal to 30 by the central limit theorem, you can say that you can use that as a reason to be able to use the one sample t-test for population means. The next is the tails. Tails are similar to testing population proportion. So, the less than sign means it's a left tail test. So it's going to be to the left of whatever p value you get. No, t value you get. I'm right. I was right the first time. T value you get. And not equal to would be to the left or right of whatever t value you get, and you can multiply that by 2, because since it's the absolute value, the negative or positive t value will have the same value to the left or right of it, respectively. And then the greater than is the right tail test, right? It's whatever is greater than that t value. And then next we have degrees of freedom. And that's a lot different than population proportions, because population proportions, when you test for them, you don't have degrees of freedom, to where in population means you do. And for testing a one sample t-test, doing that, you'll need degrees of freedom, and that will be equal to n minus 1, n being your population size, right? And then next we have our t-statistic, to find t star, right? This is really important because if you don't have a calculator, you need to know how to find the t-statistic and also be able to read the t-table, right? So your t-statistic will be equal to t equals x bar minus mu over s divided by the square root of n, right? X bar being the population, the sample mean, mu being the population mean you're trying to test for, s standard deviation, n population size, the population, right? Power, the last thing is power. Power would be equal to 1 minus beta. And what power means, power is the chance that you reject the null hypothesis, right? So, for example, if you have a larger, what would affect it? For example, if you have a larger significance level, you're obviously going to have a higher chance of rejecting the null hypothesis. If you have a larger sample size, you have a higher chance of rejecting the null hypothesis. If, for example, the difference between the hypothesized value and the actual value of the population mean is, the bigger that is, the chance of rejecting the H null is even greater. So that all results in a greater power, right? And the equation would be 1 minus beta, like I said earlier. And you'll never really know beta if you don't know the significance level, but it's good just to know the logic behind what it means. And if you call right now, I can even give you calculator tips. You won't even have to use the t-statistic. Okay, so no one called right now, so I'll just give you calculator tips. So on your calculator, you're going to want to go to Stat, Test, and press 2. That would be the t-test, the one sample t-test for population mean, right? And then you can either enter in values for a list. So if you're given a list of values, you can enter that into like L1, and you put that in, and then put in the value that you're testing for. And then you keep parentheses, and then you put in whatever the tail is, less than, not equal to, or greater than. Or if you're given all the test statistics, right? If you're given like X bar, and you're given the standard deviation and the sample size, well, you're always gonna be given the sample size. If you're given those three things, you can also plug those in, and it'll automatically give you your t-value, p-value, and all that. You'll be good to go. That's it. That's all in the package right now. And if you just pay decent value, $15.99, you can get it all.
Yeah. Hey guys, it's Mark here. I'm definitely awake, 100%. We're all good to go. My partner is Millie Bays. He taught you about our package, but I'm going to show you our package in action, alright? So we're going to do it with this scenario here. Okay, a very well-educated truck driver wants to know whether or not the average price of gas per gallon in his city is below $2.75. He decides to take a random sample of 7 different gas stations from around the city. The price of gas at each station is listed in the table below. Assume the population distribution is normal. That's important. Here are the prices. 202, $3 on the dot, 254, 194, 283, 220, and 240. What do we want to do with those prices? Let me tell you. We want to know if there is convincing evidence that the average price of gas per gallon in the truck driver's city is below $2.75. So let's do that. So we're going to use a nice little 5-step process for this problem, HMC cubed. So let's start with H. So for H, for our null hypothesis here, we want to write that mu is equal to 275, all right? And for our alternate hypothesis, we want to write that mu is less than 275. And obviously our population of interest is the gas stations, and our population characteristic of interest is the prices of gas per gallon at these gas stations. So I hope you had time to write down H, because it's gone right now. See you never. We're going to move on to our method. So for method, what we want to do is answer our QSTN. So this is going to be a hypothesis test. So hypothesis. And this hypothesis test is going to have sample data. It's going to be one numerical variable. And we're going to have one sample. So because of this, we're just going to use a t-test for population mean, all right? And the last part of M is our nice little significance level, or fishy as I like to call it. That's going to be 0.05, all right? Got it? Okay, good. Erasing. So for our next part, we need to check. So we'll do our C1 here. So there are a couple things we need to check here. First, we need to check that the sample is random. And as we can see in the problem, clearly says that the smart truck driver uses a random sample. So, my bad. So, we can go ahead and check that right off the list, all right? So next, unfortunately, our sample size is not 30 or greater. So the problem does tell us, however, that we can assume that the population distribution is normal. So we're going to go ahead and do that. So now you can see we meet the requirements to go through with our problem. So that's all for the check portion of this problem here. So now we can move on to C2, which is going to be calculate, all right? So I hope you bought the calculator package here. You're going to have a bit of trouble with this. You're going to have to write it out, all that stuff. Only $9.99, of course, for the calculator package. We're just going to press on this, go here, do this, hit that there, and there we go. We're done. It's that easy. So what we get is t equals negative 2.19, and our p-value is going to equal 0.035. P-value is looking kind of small. So here's our calculate. Hope you got those numbers because you'll never see them again. And finally, we're going to move on to C3, which is our communication of results. So as you can see from that small p-value, it's actually going to be less than our significance level. And what that means is we are going to reject our null hypothesis. Yep. And so now that we've done that, we can write that there is convincing evidence. I'm a really slow writer, so I won't write this all out for you. But there's really convincing evidence that the average price of gas per gallon in the truck driver city is below $2.75. So we're done. We did it. And you can do all the problems in the world like that. All you need to do is buy our package for a small price of $95.95. Thank you. Mark out.